Hi, this is Chet Arnold, and we're going to talk a little bit about Step 2, mapping drainage patterns. This video is part of a pair because we definitely recommend that any mapping exercise be paired up with going out in the field, and we'll talk a little bit more about that. So the map isn't the end-all and be-all. The map is really to give you a very good idea of where the water is going, because otherwise you're not going to be able to tell the difference between connected impervious surface, which goes right into the storm drain system and creates a problem, and disconnected, which may just drain to pervious areas and not be a problem. So here's the outline of Eagleville Brook Watershed in blue. And I put on the brook itself, and you can see the brook coming up through here. And let's zero in on this very central, dense part of campus where you can't even see the Eagleville Brook line, and that's for a very good reason, because it dives underneath campus and is basically totally in a pipe at that stage. So one of the first data layers we can bring to bear in terms of looking at drainage obviously is topography. I hope you can see these skinny little black lines. So here's the 650-foot line, over here the 625-foot line, 600 is down here. So in general we can tell that the direction of flow would normally be from upper left to lower right, like this down the hill, and then a little bit more complicated like this. So basically along with the road. So that's a very useful data layer to have, just to give yourself a general lay of the land and the way things are flowing, and you can get that from the state, from the CT Eco website. Well, we were lucky enough to have a number of different data layers here that we would be able to get from the town and from the university in this project. So if we look at our stormwater drainage, the main thing that we want to look up that pops up are these little squares, and those are the storm drains themselves. So let's zoom in on here. These were actually a separate data layer that we inherited from the university, but we noted that it wasn't all that good or all that accurate, didn't line up very well. So we had a graduate student go through the high resolution imagery and just pick them out. So if I turn them off and on again, you can tell that from imagery of this quality and better, if you see this little black triangle, this little black triangle here, there's one here, there's another one here, and I turn on the storm drains, you can see that you can map them pretty effectively using high resolution imagery. So now that you have the drains and you have kind of the slope, and you're able to start telling which parts of this impervious cover are connected. Certainly this whole roadway is connected, and probably this parking lot, and you can start to get a feel for that. Well, lastly, we were lucky enough, and you may or may not have this in your town, to have a number of utility-related data layers. And here we're going to look at the stormwater systems. So here are the pipes. So with the storm drains, you can tell where things finally dive down on below, and now we're completing the picture and seeing where the water goes once it goes underneath into the drainage system. Now, again, these are not always completely accurate, and we'll talk more about that in our field video, but you can see these are junction boxes, some storm drains, although not as accurate as ours, I would say, and then the pink lines are the actual pipes. So you can get a feel that the water will come down this hill, it'll go into that drain, into here, and perhaps over to here, then go right under the road and over to the other side of the road and campus, and right under that building down into Eagleville Brook. So there's a lot of connected impervious cover. Let's just go move a little bit to the northwest if I can find this area. I probably should have zoomed up. Nope, there it is. Now here's a little recreational area. We have tennis courts, and I guess these are handball courts from the shadows, I'm not sure. Now you can see, again, there's 650, 625. The water is draining from top to bottom, but we don't seem to have any stormwater pipes at all except for right under this road, and there are no drains that I can see other than over here on the road. So it's likely that even though these two are impervious surfaces, that they're draining this way onto this grassy area, and may or may not be connected. They certainly are worth looking at, and then you may be able to take them out of the equation, although this grass looks pretty compacted from here, so it may make it to the road. Anyway, that's the way you can use these kind of data layers to look at connected impervious cover and how it relates to the drainage in your watershed.